So yeah, engineering analysis 4, and today we are going to do a recap of mathematical application in system discretization processes. Okay, now we are going to start with this topic, which is a simple mathematical model. Okay, so now if you've not seen the introduction to this series, please just check it out. I'll leave link to the video in the description box, or you can just click here. Okay, I think here or here, one of the places, just one of the sides, you will see the video. Just click on it to get the introduction to this video series on class recap. Okay, of course. Oh, you just watch the video and see. Let me not repeat the whole thing here. So let's go straight into what we have today in this video, this class recap on the course engineering analysis 4. Okay, what we are going to do here, maybe you may have it in engineering analysis 1, 2, whichever one, but for us in our school here, it is engineering analysis 4, which is FCE 302. Okay, so yeah, I'm here with my notes, of course. So just stay within what was given in class, and just a recap. Of course, this is not a substitute to your main studies. Okay, your main studies. All right. So let's go now. A simple mathematical model. Just bear in mind that we are trying, or what we are doing is this, or what we are to do is this: express the essential features of a physical system or process in mathematical terms. That's it. Take a physical system can be an object or anything. Take a physical system, or maybe a process. Take what defines that process. That's the essential features. Take them and express them in mathematical terms. That's mathematical modeling. Okay, so the kind of general form of this mathematical model we have is this, which we've written as equation 1. Okay, we have a dependent variable, and then that dependent variable equals independent, of course, function of independent variable, parameters, and then forcing function. Now, I know this equation appears simple and basic, but this expression here can range from simple algebraic expressions or equations to complex equations, derivatives, things to do with calculus. So what we are doing right here now is just to show you the basic form. So this, all you have here is the basic form. Okay, so the next thing that we are going to do here is to define what we mean by this, what we mean by this. What we mean by dependent variable, what we mean by independent variable, what we mean by parameters, what we mean by forcing functions, and things. Yeah. So when we say dependent variable, we are talking about a characteristics that reflects how a system behaves, or the behavior of a system. So let me just put this out here. So let's say, for example, this as our system. So if we have this as a system now, okay, what reflects the behavior of this system is known as the dependent variable. So not just the behavior, but the state. Okay, so the behavior or state of the system. So let me just put out a formula that was given in class, very common, which we can simply make use of to give example. Now, of course, we all know this is Newton's second law of motion, which is net force is equal to the mass and acceleration. Okay, so of course, what I just said now is the mathematical expression of it. Okay, so in this equation here, Newton explained a physical process or a physical system, okay, where the net force equals the mass and acceleration. Okay, like from what was given in class, I will define everything we have in equation 1, okay, using equation 2 to explain them. Now, the first thing we have there is dependent variable. So for our dependent variable, we've said that it reflects the behavior of a system or states. So this is our system here. Now, what can reflect the behavior of this system or its states from equation 2? Now you can pause the video and make a guess. From our definition, pause the video, make a guess. Put it in the comment section. Okay, now the answer is acceleration. Yes, acceleration. Now, acceleration, because acceleration tells us how the system changes velocity with time. So since, of course, that's change with time, how the system increases and how it changes velocity with time, it's the behavior of the system. So since acceleration tells us the behavior of the system, therefore it is the dependent variable. And okay, so what we are doing now, we are trying to cast or reflect equation 2, like tell what we have in equation 2 in equation 1. I hope you understand. Okay, so now the next thing we have independent variable. So from equation 2, what is the independent variable? Okay, now let us define independent variable first. When we say independent variable, we are talking about a dimension that has to do with time or space along which the system behaves, along which the system behavior is determined. Okay, so to determine the system behavior, it has to happen within a given period of time, and of course space, or you understand. So that dimension, time and space, that is the independent variable. Okay, those are the independent variable, especially time. So do we have time in equation 2? No. That means we do not have an independent variable in equation 2. Trick question. Okay. So next thing, parameters. What are parameters? Parameters are those parameters basically reflect the composition or properties of a system or the system. In this case, this is our system. Doesn't look perfect, but so what are those things that reflect the composition, the makeup, the properties of this our system here? Now, from equation 2, again, pause the video and make a guess. Right. Now, mass. Let me say this while doing some drawing here. Now, for so mass. Okay, so the answer is mass. Mass, because to know the value, okay, of mass, to know, okay, is it 50 kg, is it 70 kg, whatever kg. Now, to know that, you need the system, you need to know it from the system. Okay, you need the system. So the acceleration, let's zoom in a bit. So acceleration will tell us, how the system is behaving, but parameter mass, we know that from the system. Okay, and then the last one, forcing function. Forcing function are external influence on the system. So external influence on the system are forcing function. Of course, looking at this sorry. Of course, looking at this second law of motion, looking at this, it's obvious that net force is outside the system, okay, acting on the system. So in this case now, we can have this funny diagram as this, saying force acts on the system, forcing function acts on the system, and then acceleration tells us the behavior of the system, then mass is a composition of the system. And yes, in the so acceleration is dependent, a dependent variable, mass is a parameter, force here is the forcing function, and then of course independent variable is time. All this has to happen, has to take place within a given period of time. But in this formula that was given in class here, we don't have anything to do with time. So this is just it for a simple mathematical model. Now, like what I said, or what was said in class, let me just read what was given in class. Now, the actual mathematical expression of equation 1, okay, which is equation 1 there, can range from a simple algebraic relationship to large complicated sets of differential equations. All right, now so let's move further. Okay, I think, like I said, this is a recap. I will not hit on everything, I'll just like recap. All right, now with that being said, I think we can go to the next thing. Still try to make this short. So there is looking at these equations, or looking at equation 1, because this is equation 1 is the main thing here, which is the general form. Okay, it tells us, or it displays some physical characteristics of a mathematical model. Okay, now these we have here are characteristics. Okay, characteristics of characteristics of mathematical modeling. All right, let's have that there. Now, yes, I think I should mention this. I'm making use of OneNote. This interface, this software, okay, OneNote, and there you can check out videos on how to make use of OneNote. There are pro videos. I know I'm basically making use of like notebook, so I don't make use of this most times, but yeah, it's kind of nice. OneNote is nice. So before we continue, these parts, like to arrange this in this form, okay, well, if we have A here to arrange this other equation, if we have A here, what should we have at this other side? Obviously, okay, because we just, to make A suggest formula, you divide both sides by the mass. Okay, so that's for that. Let's just call this equation 3, because we'll need it in the next video. Okay, equation 3. Now, of course, I said this is not in class. Okay, so a recap on this recap is we defined what a mathematical model is, a simple definition, a simple mathematical model, and then we give the general form, that's its mathematical expression, and using Newton's second law, we define what we have in the general form of a mathematical model, and then of course we took these as our system, for the system, and then we mention the characteristics of a mathematical model, and that's it for this video. And if you have any question or anything on this, leave it in the comment section, and I'll do well to reply and check out what's in the comment section, and I'll see you in the next video. Thanks for watching, and bye for now.